So we were talking about, I think this is where I left off. Is that right?
Yeah.
Okay. So we were doing substitution, and all the ones we did yesterday were indefinite intervals. So today we are doing substitution with definite intervals. We have two options for how to do this, and we just really kind of need to decide as a class. What took you so long, Bryson?
Oh, I was up. That's not that good medicine.
Do you have it? We have two options, and I don't care which one you do, but as a class, let's kind of decide which option we like so that I'll work the examples that way. And then if you prefer the other one, you're welcome to do that. So when we do this, if I gave you something like and I told you to integrate this from 0 to 2. Right, so what we would do is pick our u. So that's the inside, so x cubed plus 4. We do our du, which is 3x squared dx, right? And so everything is accounted for here. I've got, that's my u, that part is my du. Now here's where we have a choice to make. The 0 and the 2. Let me add an exponent. Let's say this is to the 5th. Just make it a little more interesting. So if I plug this in, that's u to the 5th du. Now this 0 and 2 are the x values. So you could choose to go ahead and integrate this. Plug your x back in, and then evaluate from 0 to 2. So that's option 1. Basically, just like normal, you plug your x back in, and you put in these original values. The other option is to change these values so that they are u's. So for instance, u is x cubed plus 4. So if x is 0, 0 cubed plus 4 is just 4. So in terms of u, this switches to a 4. If x is 2, 2 cubed plus 4 is 12. And so you could choose to change those limits. If you change them, then those are the u values, so there is no need to ever plug x back in. You just evaluate from here. So you either have to plug x back in at the end and then evaluate, or you change your limits to match the u values, and then you just keep it in terms of u to evaluate. Which way do you guys think?
I think the first one is going to be the new.
You want to go ahead and keep it in terms of x and put your x back in?
Honestly, either way, it's fine.
Don't matter to me.
Nobody's going to argue against you. Maybe I'll go back and forth between my two ways, and that way
So,
the 2/3 of our class that doesn't speak, if they have a different opinion, I'll make them happy as well. All right, so let's look at this one. What would you pick for your u value?
31 is
So du is
negative.
2x. Okay, one thing I noticed yesterday. Du is not what you still need in the problem. Okay, du is literally the derivative of u. So you have to do this derivative. Then we have to figure out how to make that what we need in our problem. Okay, so we have accounted for this 30 minus x squared. I need an x and a dx. I do not need that negative 2. So that means negative 1/2 du would replace the x dx. So I'll kind of simultaneously work out the two ways. You pick which one you like and you follow along with that one. Ultimately, it starts out the same. We're plugging in, this would be 1 over u squared. Can I write that as u to the negative 2? And then we have a negative 1/2 to u, so I'm going to put my negative 1/2 in front. Okay, we have limits. If you are going to plug x back in the end, though, you need to be really careful, because if you put them here right now, you might accidentally plug them in too soon. So it's kind of up to you how you want to keep track of that. A lot of times I might just leave them off and then at the very end put them back. If you did choose to go ahead and change them, if u is 3, that's 30 minus 9, so 21. If u is 5, that's 30 minus 25, which is 5. So if you want to go ahead and change them, it would look like this. If not, it looks like this. Okay, we do our antiderivative. So add 1 to the power. So I need a negative 1 in front, so that would be a 1/2. We don't really have to worry about the plus c, though, because we are going to plug in numbers. So if you kept it in terms of u, but you didn't change your limits, now you change the u back to 30 minus x squared to the negative 1 and evaluate from 3 to 5. Okay, if you did this one, you have 1/2 u to the negative 1, and you're evaluating from 21 to 5. And the answer should be the same no matter what. So if we plug in, so if I put in 5, 30 minus 25 is 5 to the negative 1 to 1. So you notice once we plug in, we get the exact same thing. So it is 100% up to you whether you change the limits or put x back in at the end. Is that one okay? Raise your hand if you prefer the option on the left. Everybody has to raise their hand at 1 of the 2. Raise your hand if you like this one. Okay, raise your hand if you like this one. We are 50-50 split. So you do whatever you like. All right. Let's take a look at this one. Keep in mind, when you see sine cubed of 2t, that means you have sine of 2t to the third. And we have a cosine 2t. So I'm trying to decide what to do for my u. Which one would u be? That inside part there, the one with the higher exponent. Right, du. Derivative of sine is cosine. Angle stays the same, times the derivative of the inside. Derivative of 2t is 2. I'm going to get a dt. So if I'm looking at this, I need the sine of 2t. I need the cosine of 2t dt, but I do not need the 2. So divide that over, so 1/2 du is cosine 2t dt. How are we doing with this? And recognizing when we need to divide things over, is that okay? So when we plug in, the sine of 2t becomes a u, so we have a u to the third. The rest of it gets replaced with 1/2 du, so we have a 1/2 u to the third du. And keep it like that and plug back in at the end if you want to change your limits. If u is 0, 2 times 0 is 0, what's the sine of 0?
0.
If if you put in pi over 4 times 2 is pi over 2, or 90, sine of 90 is 1. So if you change them, the new limits are 0 to 1, or you can keep the original. Right, antiderivative, add 1 to the power. So we need a 1/4 in front times the 1/2 that's already there, so that's a 1/8. If you didn't change the limits, now at this point, you replace your u with the sine of 2t. So then you evaluate. 2 times pi over 4 is pi over 2, sine of pi over 2 is 1, 1 to the 4th is 1. 2 times 0 is 0, sine of 0 is 0, 2 to the 4th is 0. Over here you get the same thing. So final answer is 1/8. Alright, let's do another one together and then I'll have you guys try one. What should our u be? Du, what is the derivative of x plus 5? 1, so just 1 dx or dx. Okay. I've taken care of the x plus 5, and I've taken care of the dx. But we have a problem. What do I still need to replace? The x. How do I figure out what I can replace x with? Yes, go to your u expression. If you solve for x, that means u minus 5 is equal to x. So I will replace that plain x with the u minus 5. So I have the interval of u minus 5 times the square root of u, or u to the 1/2, du. Why is this better than what I started with? It's still a product. Yeah. We just have a single term to the power. That means I can distribute it through. So that would give me u to the 3/2 times 5u to the 1/2. D. If you do change your limits, if x is -4, -4 plus 5 will be 1. If x is 4, 4 plus 5 will be 9. Or if you choose not to, then don't worry about it. You'll just plug your x back in at the end. So antiderivative, if I add 1 to my power, that's 5/2, so it would get a 2/5 in front. Add 1 to the power, that's 3/2, so it needs a 2/3 times my 5 would be 10/3. And then at this point, plug back in your x if you need to, or you can evaluate from 1 to 9. Put in a 9, square root of 9 is 3. 3 to the 5th, 2.
No, strange. Thank you, ma'am. You can't believe y'all didn't say thank you, right? Oh, that door open. God, Sarah, we need you. Hi, Dad. Thank you, sir.
Would it be 4 from 4 to 4?
If you put the x back in from -4 to 4, yes. I changed my limits this time, but if you put your x back in, you're plugging in the -4 and 4. And let's work it out and see if we get the same answer at the end. Do we actually have limits to plug in on this one? So what do we have to remember for our answer?
Plus two,
Okay. What did you pick for your u?
so put sine two.
Okay. So let's hold on and just talk for a second. If we did that, derivative of cosine t dt, that all looks promising, right? But here's the problem. Cosine is in the exponent. Do we want du to be in the exponent? No. So while that was a good start, it kind of created a problem for us because we need u in the exponent, not du. So let's flip it around. So u would have to be cosine, which means du is negative sine t dt. We don't need the negative, so negative du sine t dt. So we'll integrate from e to the u, and we need a negative and a du. What has a derivative of e to the u?
Natural logarithm.
That's, oh, you're thinking like inverse.
Oh,
Remember with e's, what happens when you do the derivative of an e?
oh, it's just e.
It stays, doesn't it? Derivative of e to a power is still e to that power. So the antiderivative is still e to the u. The derivative of u is just 1, so we don't have to undo any chain rule. We just have to keep the negative in front. Since we don't have numbers to plug in, it would have to get a plus c, and then since I'm not plugging anything in, I have to put it back in terms of the original variable. So I have to plug in the cosine of t. One more for today. What would our u be? Now this looks a little bit scary because we have multiple variables, but the fact that I said dx at the end tells you x is the variable, a is just a constant. So when I do the derivative, since a is a constant, the derivative is 0, minus the derivative of x squared would be 2x, and that gets a dx. I don't need the negative 2, so we divide that over. So I'm going to do my antiderivative. I have a negative 1/2. Square root of u would be u to the 1/2. du, you can keep it like that if you change your limits. If x is 0, get a squared. If x is 9, I get a squared minus 81. Definitely not pretty, is it? Okay, antiderivative. Add 1 to the power, so 3/2. Reciprocal in front, so 2/3. So you have to think negative 1/2 times 2/3. So negative 1/3 u to the 3/2. If you went this route, you plug your u back in. I'm going to evaluate from 0 to 9. If you went this route, we are plugging in our new limit. And we should get the same answer either way. A squared minus 81 to the 3/2. I can't really work that out. If I put in a squared to the 3/2, power to the power you multiply, that's just a cubed. You get the same answer either way, and that's really all we can do. What questions do you guys have? So I'm done for today. You have time to work on your homework. Remember, this handout is due Monday. Monday, we will practice substitution some more.